Yes. Welcome everybody to this meeting about what science can do for you and what you can do for science. This is Broadcasting ADHD Europe. I am Hans van der Velde. In daily life, I work as a coach, and next to that, as a volunteer, I work for the Dutch Association for ADHD and Dyslexia, and I'm in the board vice president of ADHD Europe. These webinars and meetings are organized by ADHD Europe. Today, we have a meeting, so we can have a discussion after the two presentations that will follow. And we especially welcome Jeanette Mostert and Cardoso. Thank you for being in our Broadcasting ADHD Europe, both of you. I hope you can both introduce yourselves. Shall we start with a short introduction of both of you? Please, Jeanette, can you start?
Sure. Yeah, I also, in my presentation, I actually have a short introduction to myself. So I will keep this very short and then give a little bit longer this introduction in a few minutes. But I am Jeanette Mostert. I work at the Radboud University Medical Center in Nijmegen in the Netherlands. And I'm a dissemination manager, and I will tell you what that means in a few minutes.
Thank you. Dana.
Yes, I'm Cardoso Melo. I'm a PhD student at the University Medical Center Groningen in the Netherlands. And my research focuses on reward processing alterations and mental health conditions.
Thank you.
Okay. So, yeah, thank you, Hans, for inviting me to give this talk and to join this webinar. So the topic, as Hans said, is like, how can science help you and how can you help science? Well, I'll show you the next slides because I have 3 goals basically for today. I will start first with sharing you some results from the CoCA project and tell you everything about this project and share some results with you, which basically is telling you how you can benefit from the science that we've been doing. And then next, Dana will tell about his research, which is also part of this CoCA project on reward processing in ADHD. So the first part will really be about sharing results from science that might be relevant for individuals with ADHD. And then in the second part of this meeting, I would like to really discuss with you how you can help us. So how can we have this dialogue and more engagement between individuals with ADHD and scientists investigating ADHD? So that's my main aims for today. So as I said, I was gonna give a bit of an introduction of who I am, because I said I'm a dissemination manager, and that's a very vague term. So I thought I'd give a brief summary of who I am. So I'm a neuroscientist, as you might be able to see from this nice brain in my background. And I did my PhD research on brain connectivity in adults with ADHD. And I did that with Professor Barbara Franke, who is here. Can you see my mouse? Oh?
Yep.
Yeah. So she's a professor in Nijmegen. And she's an expert on also the genetics of ADHD. And during my PhD, I was actually involved in quite a lot of science communication activities. So afterwards, she asked me, she said, well, we just started this CoCA project and we need a dissemination manager. And what this means is that she needed someone to translate the science from this project and convey it in messages that are understandable for clinicians, individuals with ADHD, the general public, etc. So that was my task, and that's also what I will be doing today. So as a dissemination manager, I will be telling you about the main findings of the CoCA project. Now I'm also involved in the Eat2beNICE project. That's with Alejandro Arias Vasquez, who is also in Nijmegen. You might have heard about this project because it's really cool. It's about these bacteria that live in your gut and that might have a role and they probably influence the brain. And they might also play a role in ADHD. And we know very little about it. But I will not have time to really go into that properly today. So I think we'll need to leave that for another meeting. I will mainly focus on the CoCA project, but I did want to tell you that I'm involved in it. So here you can see me doing my work, telling people about our research on one of the open days, pre-COVID times when that was still allowed. I also manage this blog, the Mind the Gap blog, which is about all the research that we're doing on ADHD, and the New Brain Nutrition website, which also has a blog, which is linked to this AD2beNICE. And then I'm also involved in PRIME, which is a bit not really on ADHD, it's about diabetes and the brain, but also has some links with ADHD, although those are still very explorative. So really cannot tell you much about diabetes and ADHD at this moment. Oh, and last thing I want to tell, just as a bit of a PR, in my free time, I'm involved in this project called the Pint of Science, and it's actually an international festival, happens every year in March. And it's when scientists go to bars to tell about their science. It's really fun. It's everywhere. So I'm sure there's a Pint of Science near you. Yeah, if it's allowed again, last year everything was online, but if it's allowed again, find in March or in May, I think it is. Probably in May. Well, find your bar that's hosting scientists and talk to them and have a beer with them. Okay, so that's just about me and my work and my role here today. So my main task in all my work is to have these scientists talk to the general public. So that's been my work so far. But now I also want to go more into, and that's more related to also future plans, have the general public talk to the scientists, have this dialogue, which kind of for me is the next step. So that's what I want to talk to you about in this discussion later on. So first, let me tell you what the scientists found in this COKA project. And this COKA project ran from 2016 to 2021, so it finished this summer. Although, of course, science is never finished, so we're still doing a lot of analyses, and well, Denner is working on a lot of great data, so he will tell you about that. Yeah, the money ran out. Let's say that the funding from the European Union, that's now finished, and now we're just waiting for results. So the idea about this project is that individuals with ADHD, they are often diagnosed with additional conditions, and these are called comorbid conditions, which is not a very nice term, I have to admit. It's a bit of a clinical term, but yeah, you can call them additional conditions, but that doesn't really sound nice either. So let's call them comorbid conditions and realize that this is a bit of a funny term. Funny, not very nice term, actually.
It sounds morbid.
Yeah, exactly. I don't really like it. Okay, you get used to the term. It's just a word. So individuals with ADHD, they have these comorbid conditions. And if you have multiple conditions, whether they're a mental health condition or physical conditions, they increase your burden, right? Your disease burden is in a way, and reduce quality of life. So it's a really big issue. And we don't understand really why these conditions happen together. In this COKA project, we focused on depression, on anxiety, a bit of bipolar disorder, but actually I will not go too much into that because it was kind of part of, well, in some studies we looked at depression and bipolar disorder together, substance use disorder and obesity. And yeah, so that's what I will be focusing on today. There's of course other conditions, but these were not really part of the project focus. And we had a few questions. So one of the questions is, how frequent is this overlap between ADHD and these conditions? We know that it's there, but there wasn't really any good data on how frequent this overlap is, right? This is more of a gut feeling or something that's like anecdotal evidence, or is there real evidence that this happens a lot? We wanted to know, are there differences between men and women? You know, is one condition, is that more frequent among men with ADHD compared to women with ADHD? Because that's also important to know, especially also when you want to treat people or prevent these comorbid conditions from occurring. Then we wanted to know, can genetics explain this overlap? So part of COKA, there's a lot of researchers interested in genetics, and they want to understand, can the genetics explain why these conditions overlap? Of course, genetics cannot explain the whole story. There's also a lot of other factors that play a role. We call these environmental factors, but environmental factors can be anything that are not, well, that are not genetic, basically, right? So that can be, for instance, if you were preterm born, then that can be an environmental factor, or it can be trauma in your childhood, or it can be toxic substances maybe in the water. That's in historical data. There was some occasions of that. So those are environmental factors. But we focused here on the genetic aspects. Then we want to know what role does dopamine play in this overlap. There's a strong hypothesis or a theory about ADHD that this is mainly related to the dopamine system. It doesn't explain everything about ADHD, it's just an aspect, but it is an important aspect of ADHD. That the dopamine, it's a molecule that's very, has many big, many functions in your brain, called a neurotransmitter, if you've heard of that word. So it's a substance that's really important for many different brain functions, and it's quite central to ADHD, and also a lot of ADHD medication. So stimulant medication like Ritalin or Concerta, they trigger the dopamine system. So we wanted to know what role does this play in this overlap. And then lastly, we want to know, can these comorbidities also be prevented or reduced with therapy? And then specifically, therapy are treatments that not related to drugs, so that we call non-pharmacological, so non-drug related treatments. And here we focused on exercise, so physical activities, and bright light therapy. So those were the central questions of the CoCA project. So I'll go through some results and main messages. I will definitely not be able to show you all results of the CoCA project because it's a lot, but just some highlights, let's say it like that. So we found that more than 80% of adults with ADHD suffer from a comorbid condition. So that's really, really a lot throughout their lifetime, right? So at one point in their life, it doesn't have to be all the time, but throughout the life course, 80% of adults with ADHD have a condition, an extra next to their ADHD. So it's really prevalent and really important. We also found that depression, anxiety, and to a bit lesser extent, substance use disorder are more prevalent among individuals with ADHD compared to individuals without ADHD, right? So if you have ADHD, the chance that you have one of these three conditions is higher than if you don't have ADHD. And we found that depression and anxiety are more common in women compared to men with ADHD. So this is also in the people without ADHD, this is also more prevalent. So women are more likely to have depression or anxiety compared to men. If they have ADHD, the women are also more likely. Right? So it's, the difference gets bigger actually. And with substance use disorder, it's the reverse. So men are more likely to have substance use disorder. But in one data set, we found actually something interesting that seems that young women with ADHD, they seem to have a bigger risk of having substance use disorder. So this needs to be further investigated, but it's quite an interesting insight. Like, okay, what's going on here? Is there an increased risk for young women with ADHD to develop substance use disorder? So these are just some statements. So I'll show you a bit of results to get a bit of a feeling of it. So this is one data set that we looked at. So we looked at much more, but this is a really big data set from Sweden, where they have registry data. So they have this population data set. There's almost 5 million people in this data set. So it's really like not population wide, but really a lot of people between 18 and 64 years. And they looked at how often do these people have a clinical diagnosis. And you see that these are the men without ADHD, the women without ADHD, the men with ADHD, and the women with ADHD. And you see that they much more often have anxiety disorder, major depression, and substance use. This graph basically shows you what I just told you. And in the other data sets, we also looked at big Norwegian data sets and German data sets and Danish data sets. So really different data sets. They didn't show the exact numbers. So the prevalence of these conditions, they differed a bit because these data sets also have their own intricacies, like the age people had and the way these diagnoses were recorded, but the pattern was everywhere was very similar. So this is an important message, right? Anxiety disorder, major depression, and substance use disorder are more prevalent among ADHD individuals. I will come back to obesity a bit later, so bear with me. The next question is, can these genetics explain this overlap? So now, this might get a bit complex, so just bear with me. If you don't completely follow, that's totally fine. We'll get to the main message a bit further. But you might know these are like schematic representations of your DNA. that contain your genetic material. And the little lines here, they are like the single codes, like the letters in your DNA. So your DNA consists of different letters, and they all like a long code of different letters. And if the letter differs, this is called a genetic variant. So I might have one variant, Hans might have another variant, Dana might have another variant, right? This is why we're different. And what we can do is look at which of these variants are more frequent among individuals with ADHD compared to individuals without ADHD. Yeah, and it's important to realize that these single genetic variants usually have very small effects. So it's not that if you have this one variant that you then automatically have ADHD. It just means that all these little variants together increase your risk of having ADHD. So that's what we did. And very complex graph here. But what's important to know is that some of these variants, so that's these little dots here, these are, we say significantly, so they have an analytical threshold where we say, okay, these are more frequent among individuals with ADHD compared to those without ADHD. So what we can do with all this information is kind of compute a genetic risk score for ADHD. So based on your entire genetic makeup, what's your kind of genetic risk that you can have ADHD? What do all the variants that you have combined, do they kind of have this profile, could be ADHD, or do they have a profile less likely to have ADHD? That's kind of what it says. You can have a very high genetic risk score for ADHD and not have ADHD. So it's not that deterministic, but it does give you an insight. And what we can then do is look at another data set where we know of different traits of people. So we know their genes, their genetic makeup, and we know a lot of their other information. So tobacco use, BMI, alcohol intake, anxiety, depression, etc. And what we can then see is in all these different people, we kind of compute this genetic risk score for each individual and then see how high is their BMI, do they use tobacco, do they have depression, etc. So we kind of correlate the genetic risk score with these traits. And then we can see, is there a genetic overlap between ADHD and these traits? That's the main message. So we look at the genetics and we look at their traits, so like tobacco use, depression, etc., and see if there's an overlap. I hope that's a bit clear. Then we get these super complex graphs, but I just wanted to point out this. So there's genetic variants linked to ADHD. So that's this genetic risk score, correlate with depression, anxiety, also traits like mood swings or loneliness, alcohol intake, tobacco use, and also BMI, which I will get to it. Yeah, so if you, for instance, if you have this high genetic risk score for ADHD, there's a bit higher chance that you also have mood swings. So this is interesting, right? Why would you have that, right? So this says something that there's a genetic link. Okay. Just as a summary, for in case you got lost, here's a summary that I'm stealing from Professor Brooke Cormand, who is a key geneticist in our CoCA project, and he wrote a blog on this Mind the Gap website, so you can also read the full blog there. But he summarizes this really nicely. He says all these results, and also of other researchers, reported in more than 40 scientific publications, support our initial hypothesis that certain genetic factors cut across psychiatric disorders and explain, at least in part, the comorbidity that we observe between ADHD and many other conditions. It's a long sentence, but I think this does summarize it well. There's a genetic basis for this comorbidity. And of course, all this research leads to new research questions, right? This is how it works in research. So now we only have more new questions. Now, I also wanted to say something about obesity because I didn't touch on that yet. So we saw that this genetic risk for ADHD also links to having a high BMI. So there's something going on there. And we looked into that a bit further. This is back to the Swedish data set that I showed earlier. Again, you see that men and women with ADHD have a bit higher risk of having severe obesity. In this case, you see the prevalence is quite low, but this was really about like clinically diagnosed severe obesity. So yeah, this is really important. Something's going on here. Why would someone with ADHD also have obesity? And you see, especially women are at a much higher risk. And then we looked into this link between BMI and ADHD a bit further, and we saw that part of the mechanisms of this overlap is related to dopamine genes. That's interesting because I told you before, dopamine is really part of this hypothesis of ADHD. So that's this publication by Nina Rotmota. She's a postdoc also in Nijmegen, who found dopaminergic genes signaling as a biological link between ADHD and obesity. So I'll show you a little bit about dopamine, although Dana will, I guess, also talk a little bit about this as well. So this is a brain that's cut in half, basically, through here. Here are your eyes, and this is the back of your brain. So this is the front, and this is the back. And dopamine, these red lines, is involved in signaling in all these brain areas. And Hans is very interested in noradrenaline, so I'm telling this to Hans. Noradrenaline is the blue lines, and the dopamine and the noradrenaline system, they're very closely linked. Yeah. So that's what you also see.
Yeah, thank you.
And innervate also the same brain areas. And what was interesting is that we found that that the dopamine genes were kind of explained this overlap between ADHD and obesity, and that also they explained the overlap between like brain structures. So that people who had like a bit smaller brain structures, they also often had ADHD and obesity, and that these genes played a role in there. So there's really a link between the genes, brain regions, having ADHD and having obesity. Yeah. So why? That's of course the next question. How does this exactly work? We don't really know, but it could be related to this reward system. So dopamine plays an important role in attention, in controlling your inhibitions, in reward, in motivation, etc. So this is what Dana will talk about. So I will leave it to this. But this is our hypothesis that the reward system is involved. So basically, that the genes that are related to dopamine, something's disturbed there. Therefore, your dopamine system is disturbed. Therefore, your reward system is disturbed, and that may cause both ADHD and obesity. That's kind of the hypothesis that we have now. It's not proven yet, but that's what we're going to investigate. So last part, how could these comorbid conditions then be prevented or treated? This is the PROUD trial that was part of CoCA, where we looked at can physical exercise training or can bright light therapy reduce comorbid conditions, mainly depression and anxiety in individuals with ADHD. So 207 adolescents and young adults with ADHD and also comorbid conditions, they participated in this trial. And what was really cool is that they participated in London, some participated in Nijmegen, others participated in Frankfurt, and others participated in Barcelona. So they didn't travel to these 4 locations, but people in London participated in London, right? So this is really nice that we tested these effects in different countries. And what they did, these people, they were randomly put into a group. So what you need to do with these trials, you can't have people choose what they want, right? You can't say, do you want to do the physical exercise? Because then probably people who like sports will choose that one, right? Yeah. Or the people who are always a bit depressed in the winter, they choose the bright light therapy. So you don't want that because you want to have the groups basically equal. Otherwise, you don't know if your effect is due to people already liking sports or not. So by chance, basically, they were put in either doing the physical exercise or the bright light therapy or the control group, which just continued their usual treatment, medication or psychotherapy. And they got this wristband, like a Fitbit kind of watch, activity tracker. They got a smartphone where they received the exercises and some questions during the day and motivations to keep going and some feedback. And this, yeah, they did this for 10 weeks. And now this ends in a cliffhanger because I don't know the result yet. This is really unfortunate.
Oops.
I will tell you, but we're still analyzing the data and then it has to be published. And only when everything is online can we share it. It will be an important story.
There's something with your sound. You sound a little less.
Can you hear me now better?
Yeah, better. Yeah.
Maybe there was a little glitch. Sorry.
Yeah.
Yeah, so when the results are out there, maybe we should have another webinar with the people involved and tell you about it, because I think this will be very, very interesting to share the results of it. To conclude, comorbidity in ADHD is a big problem. Adults with ADHD frequently have co-occurring conditions such as depression, anxiety, obesity, to a bit lesser extent, but still important, substance use disorder. Of course, there's other conditions, right, that I didn't talk about, like autism is a very big, well-known comorbid condition for ADHD. We didn't focus on that because so much is already investigated about autism and ADHD, right? It's a whole discussion on its own. So in the COKA project, we did not focus on that. But of course, there's others.
Yes, sorry to interrupt you. There is indeed, it's a colleague of yours from the Radboud who did the genetic overlap between dyslexia, autism, and ADHD. There's a huge connection between the three, and yeah. What he said, they all emerge from the same cluster of genes. So never one gene in these cases, but a cluster of 200 or whatever genetic mutations. And one person in the family gets dyslexia, the grandfather was a bit autistic, and the father is an entrepreneur and the typical ADHD. Yeah. That's what's more or less, yeah? Yeah, exactly. So we know a lot about, well, don't know, there's still a lot of research on autism, but actually these other conditions are often a bit ignored. So that's why we focused on them with the COKA project. But the story is probably a bit the same. There's a lot of genes, a lot of genetic variants that play a role in, yeah, you could develop ADHD, you might develop depression, but maybe you develop depression because your ADHD was not diagnosed. So we don't still really know what's cause and effect here, right? Do you develop depression as a result of ADHD, or is this biological makeup that you already have this higher risk of developing depression when you also have ADHD, for instance? Yeah. And then of course there's a bit of a difference between men and women in how these things emerge. Well, there's this genetic overlap that we just discussed, which of course is never the full story, but it's an important part of the story. And the dopamine system plays an important role for influencing brain processes. And I think the main message from the COKA project is that, especially those that treating ADHD, but also individuals with ADHD themselves can be aware of this. It is important to also be aware of comorbid conditions because they really are the rule rather than the exception. And it might be really important for treatment, whether, do you treat the depression first, or do you focus on first treating the ADHD? And might that already reduce depression? Or if you treat ADHD on time, does that then prevent other conditions from occurring? So it's really important that people are aware of that. If you have one condition, basically, there's a big risk of developing others, and that might be prevented if you have the right treatment at the right time. If you want to know more, these are some links. Maybe Hans can share them, or I can put them in the chat also if people want to look them up. Or you can just Google them and you'll probably find them as well. So this is the COKA project, the Mind the Gap blog. There was a very nice interview, online radio interview with Professor Andreas Rijf, who's the coordinator of the COKA project, and Catharina Hartman, who is also the supervisor of DENER, and has done a lot of these research on these big registries, so really about the prevalence of ADHD and these comorbid conditions. So that's a very nice interview to also listen to. And there have been previous webinars by Professor Barbara Franke at Broadcasting ADHD Europe, and also by Professor Antoni Ramos Quiroga about ADHD and substance. So we have a webinar in the Broadcasting ADHD Europe YouTube channel. There's a webinar with Professor Ramos Quiroga about substance abuse, and a webinar with Barbara Franke about state of the art of science. So you can look at that.
Yeah, highly recommend them. And this is all the other projects that I didn't get to talk about, but that you can have a look because they're very interesting and you have questions. Well, that was my part of the story for now, I think.
Yeah, maybe unshare for a moment, maybe you go back, but then you can share again, because I would like to start for the discussion. I hope people are coming into the discussion later on, but a very good question from Stephen, who says, in fact, there isn't one gene or one small cluster of genes responsible for ADHD. Indeed, that's what you meant also, which makes research more difficult. Am I right? So that's two things.
Yeah.
It's...
Great question, Stephen. Yeah. How do you say? So there's in genetics, we call them, so some conditions, they're called monogenetic conditions. So there's one gene, and if there's a defect or like a mutation or something wrong in that gene, then you have this condition. And then those are often very severe, right? So there's some examples of, for instance, some breast cancer genes that if you have that mutation, then there's like an 80% risk of you developing breast cancer. So there's more of these examples that I can't think of now, but there are some conditions that really have like these huge effects. And ADHD, and actually most mental health conditions, they're not like that, right? So there's these small differences that kind of add up. And that's the nice thing of these genetic risk scores, is that they take into account all these small differences and kind of give you, how do you say? Yeah, a score, kind of, which sounds a bit deterministic, and it shouldn't be interpreted like that. But yeah, with that score, you can have a higher risk of having, there's a higher chance that you also have ADHD. There's always exceptions to this rule, right? So there's always people who have a very low genetic risk score and still have very severe ADHD. And there's people who have like a sky-high genetic risk scores and have 0 symptoms, right? So this is life, right? But yeah, indeed, there's many genes responsible, and we still don't know all of them. So then the interesting thing is also that until a couple of years ago, a lot of research in ADHD was based on dopamine genes. So we knew something was related to the dopamine system, so we focused on these genes, right? And then there's this graph that I showed you with all the blue little dots, right, with the stars. Those identified kind of new variants, and none of these like top variations were related to dopamine. So that's interesting, right? So it's really not the entire story. It's much more complex. Yeah.
In general, I would say that at least when we're talking about ADHD, we're maybe in the brain science in total, there is never one cause. Of course, as a scientist, you're looking for the cause of this and the cause of this illness, but there isn't one cause. It's like an orchestra that works together, and then maybe one or two of the violists are not really in tone, and then the drummer is a bit worried about his home situation, and then the whole symphony doesn't sound very well.
I like that analogy, Hans. That's really nice. Yeah.
So
like your brain is a bit like an orchestra, and if one person's not paying attention and if the rest of the orchestra is good, you don't really notice it, and you're angry. But if everyone, if more things go wrong at some point, or maybe something else, if the acoustics in the room are very bad, then the orchestra can play as well as they can. But
what I would like to ask you, I would like to, when I see these graphics you show, my brain tends to turn things around. Hey, let's take alcohol abuse. Only alcohol abuse. What we know in practice, for me as a coach, but everyone who is connected with ADHD, we know alcohol and other drugs are we call it self-medication. And if you ask, so we attribute it to the behavior. Like, well, you were 12 or 14 and a bit restless, and then this alcohol came in. Oh, this feels relaxed, I want more. So and so you are self-medicating with all kinds of drugs, for example, alcohol. So can we turn it around? When I saw your graphics, I would say everybody who comes in by at the psychologist or the doctor or whoever and has symptoms of alcoholism, we do need to check them on ADHD. Imperative. It's not saying everybody who uses too much alcohol has ADHD. Of course not. We know that. But could we prescribe the doctor to to always look into ADHD. Same for obesity, because the graphs you showed, I suppose you didn't manipulate it to make it look a bigger difference.
No, I didn't do anything.
No.
I print screened them out of the publications.
yeah. So I would say that every doctor or psychologist or whoever has to realize that if something like that is the matter, you always have to check ADHD. Could we?
Yeah, it's a good idea. Yeah. So of course, so what I said, there are correlations, right? So we don't know if the ADHD is causing the alcohol use, or the alcohol use is causing the ADHD, or that, is it the genes that make you more likely to use alcohol, or is it your impulsivity that makes you more likely to try it, or is it indeed self-medication? So there could be many explanations, right, for this correlation.
Yeah, sure.
But indeed, you're right. It could be a trigger that we say, well, if someone needs the alcohol use, but I think also depression is a very important one. If someone comes to the family doctor with depressive symptoms, might be good to check if they might actually have ADHD. Yeah, and indeed, yeah, with alcohol use, it wouldn't hurt, I think, to have such a screener and have that.
Yeah. So and I think you as scientists have the authority. I know that's difficult because you have the authority, you don't want to say things you cannot really prove. So that's difficult, but at least we as ADHD Europe and all these ADHD organizations and you as scientists together, we could broadcast to the doctors, etc. Please always check on ADHD in these cases. And maybe give them some extra instruments to make a difference between non-ADHD alcoholism and ADHD alcoholism.
Yeah, I don't know the numbers of how many people with alcohol use disorder actually also have ADHD, right? That's the other way around. Yeah. And we didn't test that, but yeah, I think it could be important to have that as a message.
Yeah,
at least,
very
applicable.
Yeah, at least think about which message should we give them then. That brings me to the content of the genetic mutations. Maybe I didn't listen well, but I only the dopamine is mentioned. But you know certain genetic variants. What does one variant do that we can explain the alcohol use or the obesity, as well as the ADHD? Where is the functional connection? In fact, you were only talking about a statistical connection.
True. Yeah. So this is what Nina Rotmota did in her paper on obesity and ADHD. She really looked at some variants, and then I didn't show this because it was getting too complex, but she really made a model with all like this gene encodes for this molecule, which is part of this like synapse where it's influencing these molecular mechanisms that can important for dopamine signaling, right? So she really looked at it, but it takes a lot of time and effort, right? Because you have to really dive into, and for every variant, have to see in which gene it is involved. Not every variant is involved in the gene. Some things we don't know their function of yet, but for some we do, and then we can look at, okay, so it's involved in this molecular pathway, basically. So it's probably involved in producing a bit less dopamine, or in some molecule that detects dopamine that then functions less well, or that breaks down dopamine that functions less well, etc., etc.
Oh, okay.
But that requires a whole different lecture.
So there is hope for the future that we really understand on the functional level what all these variants do. Yeah,
I think so. Yeah, but then of course you don't know, for every individual it will be different.
Yeah, sure. Yeah.
But maybe we should move to dinner.
Yeah, let's move to dinner. And there's one
I'll
question
have
left.
Look at all the questions in the chat until now, and then maybe
well, we can take them on later. There's one from Stephen. We'll see that later. Yes, Daner, go ahead.
You should be able to see my screen now.
Yeah, sure.
Yes. Yeah, so I already introduced myself, and as I said, I'm a PhD candidate at the UMCG, and In this talk, I'm gonna talk a bit about rewards and ADHD. In my research, I don't focus only on ADHD. As Jeanette said, there's like different conditions that are comorbid with ADHD. So I also investigate them, but here I'm gonna focus on ADHD. And I always like to start my talks on a bit of the, like, what is a reward? So a bit of the concept of a reward. Some people might think of video games or getting a good grade at an exam or receiving a gift for behaving well. And actually all these examples are examples of a reward. Basically, reward is any stimuli with the potential to make us seek and consume them. And if we like, so if we have that rush of pleasure, we'll probably want to get them again. And why are rewards important, so important for us? First of all, it guarantees that we stay alive by eating, by drinking water, but it also influences how we experience positive emotions, how we experience pleasure, how we stay motivated to perform, and also how we learn new things. So far, rewards are good and are present in basically everything that we do. So what's specifically the problem with rewards here? To answer this question, I want you to meet Mike and Lucas. Mike and Lucas are going to a party, and during the days before the party, Mike is behaving well, so he can go, so his parents will let him go, while Lucas is helping his parents even more this week, so they can let him go. So he's even doing extra because he's really motivated. He really wants to go to this party. But once at the party, Mike is having fun, he's talking, he's laughing with his friends, he's having a good time, while Lucas is bored. He was once so motivated to go to the party, now he is just bored at the party. And after a few hours, things start to get a bit crazy, everyone is drinking, and Mike refuses to binge drink because he doesn't want to get into trouble, he doesn't want to be hungover tomorrow. While Lucas is binge drinking as if there's no tomorrow. So he's not thinking about tomorrow, he's not thinking about the consequences, he's just drinking. So we can see that Mike and Lucas are quite different here, and this is probably because Lucas has reward processing alterations. So we saw that he was super motivated to go to the party, but he was way less responsive to the reward of being at the party. And also we saw some impulsive behavior when he was binge drinking. And okay, so now that we understand what a reward is and what reward processing alterations look like, what do I do exactly? In my PhD, I investigate the relationship between reward processing alterations and ADHD and other mental health problems. And of course, why do I study this? Why is it relevant to study this? So basically, I want to look at how these reward processing alterations are linked to ADHD. And if these alterations, if we can prove that these alterations in reward processing are one of the causes or causing the development of ADHD, then we can do something about it. So we could, for example, we could prevent the development of ADHD, but also early intervene. So there are people that have a higher risk of developing ADHD, and maybe we could do something before the development of any symptoms, but also give a better quality of life. So improving therapy, improving the treatments that we have available for people with ADHD. And I'm gonna talk about two of my studies that I already did it. So the first one, I looked at the association between reward processing alterations and ADHD. So this was more like just to get to know what we were getting into it. And this is the Lifelines CoCA study. And I used data from around 38,000 people from 4 to 91 years old from the north of the Netherlands. I grouped these people into 5 groups. So I have children, adolescents, and 3 groups over adulthood. And I looked at their reward processing and ADHD symptoms. And what I found was that people with more reward processing alterations also had more ADHD symptoms. And this was the case for all the 5 groups. So both in childhood, in adolescence, but also in adulthood. Yeah, so the second study, I decided to look into the predictive role of reward processing. And this, I used data from the TRAILS study, which I had data from more than 2,500 people from the Netherlands. And this time, we not only measured reward processing and ADHD symptoms, but we followed people from pre-adolescence until they became adults. So they were measured several times over the years. And here, I looked at their reward processing when they were 13 years old and their ADHD symptoms in the future. So when they were 15, when they were 18, up until they were 25 years old. And what I found here was that people that had more reward processing alterations when they were adolescents, when they were 13 years old, they also had more ADHD symptoms in the future. So all these measurements that we did over time, they had more symptoms in comparison to the ones with less reward processing alterations. But of course, here I can only say that reward processing can predict ADHD, but the big question is it causing it? And this brings me to kind of the egg and chicken paradox. So which one came first, reward processing alterations or ADHD? And remember that in this study, I looked at reward processing when they were 13 years old. So probably they already had ADHD symptoms. So that's why I cannot say that reward processing was there before ADHD, because probably they already had, they already presented ADHD symptoms before that. So of course, there's still a lot to do. And one of the things is to look at the genetics of it. And this brings me something to what Jeanette said about the genes, the dopamine genes being related to the reward system and then being related to ADHD. So that's basically my next study that I'm starting now. So I want to see if reward processing alterations were present before ADHD onset and if they are related to the dopamine genes and the variations that are within those genes. And also, another thing that I'm planning to do is to look at the kids of people with reward processing alterations. So in this study, I want to see if the reward processing alterations are passed on through genes, but also maybe they are passed on via parenting. So the way that the parents behave and raise their kids, or how they pass these reward processing alterations, and seeing these two ways, the genetic way and the environmental way, how they are related to the development of ADHD in these kids. And of course, I don't do this alone. This is my team. So I have Robin here and also Katarina. And yeah,